When you think about evolution, you often picture this, like straight line of progress,
Right.
complex stuff replacing the old, simple forms.
Yeah, that's the standard story. But the oceans, they tell a different tale sometimes. There are things down there.
Well, they found a winning formula millions of years ago and just stuck with it.
Exactly. They kind of perfected survival way back when and
Yeah.
just didn't bother changing. True evolutionary monsters, almost.
You could say that. Biological blueprints that feel like they swam right out of mythology, or maybe a horror film.
So today, we're doing a deep dive into two groups of these extraordinary ancient fish, often overlooked, actually.
Mm-hmm.
We're heading way down to meet the ghost sharks, the chimeras, and those infamous vampire fish, the lampreys.
And our mission really is to unpack their biology, their, incredibly deep history, and the kind of specialized tools they developed.
Yeah, what makes them tick?
Right. Why are they such outliers among cartilaginous fish?
Mm.
And crucially for the lamprey, why has it caused such huge problems, such devastation relatively recently? Okay, let's set the stage first. The time frame here is just mind-boggling. These aren't just old.
Not even close. Chimeras and sharks, they went their separate evolutionary ways about 400 million years ago.
400 million.
Yeah, and get this, that split happened something like 10 million years before our own ancestors, the first vertebrates, even considered crawling onto land.
That really puts it in perspective.
It does. And then there's the lamprey. Talk about endurance. They've looked pretty much the same for 340 million years.
Oh.
They've weathered 4 out of the 5 major extinction events on Earth. These guys aren't just survivors, they're like the definition of resilience.
Okay, let's start with the first group then, the deep-sea ghosts, chimeras. The name itself is pretty evocative, isn't it, from Greek myth?
It is. The chimera monster, part lion, part goat, part snake. A hybrid.
Uh-huh.
And it fits, biologically speaking. They are kind of hybrids. They're cartilaginous fish, chondrichthyes like sharks and rays, but they're the forgotten branch.
The weird cousins, he said?
Pretty much. Everyone knows sharks, sleek predators, or rays, elegant gliders, chimeras. They took a different path, down into the dark, deep parts of the ocean, the basement dwellers.
And it really is the basement. Most live way down, cruising the seabed, often deeper than 200 meters, sometimes, 2,600 meters?
That's right. Crushing pressure down there. They share the cartilage skeleton with sharks, sure, but you see their unique path in something really basic. How they breathe.
Okay, how's that different? Sharks have multiple gill slits, right? 5, sometimes 7.
Exactly. But the chimera,
Just one.
just one single opening on each side. And critically, it's covered by this bony fleck. It's called an operculum.
Ah, okay. Like bony fish have.
Precisely. It's a huge difference. Fast sharks need ram ventilation, swim constantly to push water over their gills.
Right.
Chimeras, adapted for slow cruising in the deep, they actively pump water in and out using that operculum. Perfect for their lifestyle, not for speed.
So that really sets them apart functionally. They can get quite big, though, up to 1.5 meters.
They can, yeah, and probably live over 20 years. But despite being slow, they pack a serious punch defensively.
Oh.
You really, really don't want to sneak up on a ghost shark. Most have this venomous spine right on their back.
A venomous spine. Why would something living that deep need such a gnarly defense?
Well, think about it. They're slow, benthic cruisers, not built for quick escapes like, say, a pelagic shark. If something corners them down there, they need a get-off-me-NRW button.
Okay, makes sense.
And the venom, it's potent, can cause necrosis tissue death. The pain alone is reportedly intense enough to cause hallucinations, even paralysis and whatever's bothering it. It's a high-stakes defense. Instant deterrent.
Wow. And I read that spine. It's like a one-shot deal.
Sort of. It actually breaks off after use. But here's the thing. They regrow it. A pretty amazing biological commitment to staying alive.
Incredible. But there's a downside to their deep-sea life, especially when humans get involved.
Yeah, a tragic one. You mentioned the crushing pressure they're adapted to. What happens when a fishing net accidentally scoops them up and hauls them to the surface really fast? It's usually fatal, barotrauma. The pressure drop is too sudden, too extreme. Dissolved gases in their bodies basically expand violently. They just can't survive the trip up.
Which makes studying them incredibly difficult, I imagine.
Extremely. We learn most from accidental catches or increasingly from remotely operated vehicles, ROVs, down in their habitat.
Right. Okay, let's talk about how they hunt down there in the pitch black. They've got superpowers, right? Electric senses.
Absolutely. All 3 families of Chimaera rely on it. You can often see these little dots, pores on their faces. Those are the sensory organs.
And one group is particularly specialized. The plough-nosed ones.
Yes. The elephant fish. They have this really bizarre, fleshy snout, sometimes over a meter long. Looks like a plow.
And they use it like one?
Pretty much. They root around in the seabed sediment with it, searching for hidden prey crabs, urchins, that sort of thing.
So is that electrosense like a shark's, detecting muscle movements?
Similar principle, but maybe even more sophisticated in some ways. Sharks often use passive electroreception sensing fields already there. The elephant fish's plow seems more like an active scanner.
Active? How so?
It's lined with these super specialized receptors. It's almost like they're mapping the electrical signature of everything in the mud. Prey can't hide. Every little muscle twitch, even a heartbeat, basically screams, "I'm here," to the elephant fish.
That's incredible. A built-in sonar system for the dark. Amazing.
Totally. Then you've got the short-nosed chimaeras, the ratfish, they have those long, skinny tails, and the long-nosed ones, spookfish, out in the deeper open water with paddle-like noses, all perfectly ghost-like for the abyss.
Truly specialized evolution. Okay, let's switch gears to our second creature. Equally ancient, but maybe slightly more infamous today.
Definitely more infamous in certain places. We're talking about the lampreys, the ancient vampires.
First off, let's clear up the name confusion. People call them lamprey eels, but they're not eels at all, are they?
Not even remotely. Eels are bony fish. Lampreys are much older. They belong to a group called agnatha jawless fish.
Jawless.
Right? And like sharks and chimeras, they're skeleton.
Mm-hmm.
Pure cartilage, no bone, and no scales either, which makes them super slippery. They're one of the most ancient types of vertebrates still around.
And we're focusing on the ones that give them their scary reputation. The 18 or so species that are parasitic, blood drinkers.
Hematophagus, yep. Literal vampires. And their attack method is, well, it's something else.
How does it work? They don't have jaws, so how do they latch on?
They have this round, sucker-like mouth, but instead of lips, it's lined with rows of these sharp, horn-like teeth. They clamp down onto a fish with suction.
Okay, clamped on. Then what?
Then comes the rasping. They have this tongue also covered in sharp bits, and they basically use it like a drill.
Ooh.
Yeah. They rasp and bore right through the fish's scales, skin, flesh, until they hit blood vessels. They're essentially creating a feeding hole.
And they need to keep that hole open, right?
Yeah.
Stop the blood from clotting.
Exactly. And this is where they're quite sophisticated, biologically speaking. They secrete anticoagulant enzymes into the wound, stops the clotting, keeps the blood flowing nicely. Just like mosquitoes, ticks, leeches. Even vampire bats use anticoagulants. It's a strategy nature has hit upon multiple times. Ensures they can feed for a good long while.
How long do they feed like this?
Their parasitic adult phase lasts about 12 to 18 months. It's a feeding frenzy.
What's really wild about lampreys, though, is their life cycle.
Yeah.
It's like two completely different animals.
It really is. They start as larvae called amicoids, and they are totally harmless.
Harmless.
They burrow into the mud of streams and rivers, and for years, sometimes 4 years, sometimes even longer, they're just filter feeders, sieving tiny algae and microorganisms out of the water, actually quite important ecologically at this stage.
Okay, so peaceful start, then...
The change. Then the transformation. The juveniles are even called transformers. They morph into these smaller versions of the adults, and for the parasitic species, that's when the vampire phase kicks in.
And they start hunting bigger fish.
Big time. Salmon, trout, whitefish, sturgeon, anything they can latch onto.
This is where things get problematic, especially in North America's Great Lakes.
Massively problematic. See, in the Atlantic Ocean, where sea lampreys are native, they've co-evolved with the fish there for millennia. Fish often survive an attack. There's a balance.
But not in the Great Lakes.
No balance whatsoever. When they invaded the Great Lakes, the fish there, lake trout, whitefish had zero evolutionary defense, no shared history.
So the attacks were much deadlier.
Devastatingly so. The kill rate jumped to like 40 to 60%. Imagine that. Each lamprey could kill up to 40 pounds of valuable fish during its adult feeding spree. The impact on the fisheries was catastrophic.
How did they even get into the upper Great Lakes? Wasn't Niagara Falls a natural barrier?
It was. They were native to Lake Ontario below the falls, but then we built the Welland Canal to bypass Niagara for shipping. And improvements, deepening the canal in the early 20th century, basically gave them a highway. By 1921, they were in Lake Erie. By 1938, they'd spread through all 5 Great Lakes.
An ecological nightmare unleashed. So how do you even begin to control something like that? A creature that survived mass extinctions.
It takes a huge ongoing international effort. The Great Lakes Fishery Commission, Canadian agencies, U.S. agencies. It's massive.
What do they do?
They're pretty clever, actually. They use specific chemicals called lamprecides that target the larvae, the anticoagulants, in their streams, trying to minimize harm to other wildlife.
Okay.
They also build barriers, physical blocks, to stop the spawning adults from reaching the streams where they reproduce. And they even use pheromones, chemical signals, to lure and trap adults.
Wow. Sounds like a constant battle.
It is. Costs millions every year just to keep the population suppressed and give the native fish a fighting chance.
But just like with the chimeras, there's more to the story, isn't there? Not all lampreys are vampires.
That's a really important point. There are non-carnivorous, non-parasitic species.
How do they survive?
It's fascinating. They do all their feeding as larvae, filter feeding for years, sometimes up to a decade. They build up huge energy reserves.
Yeah.
Then they transform into adults, but they don't feed at all. They just live off those stored reserves, swim upstream, spawn, and then die within about 6 to 10 months.
So they basically live their whole adult life on savings from their youth.
Exactly. Talk about delayed gratification, an incredible evolutionary path.
Okay, so let's bring these two amazing ancient creatures back together. We've got the ghost shark, the chimera, master of the deep dark, crushing depths with its venom and electrosense, and the lamprey, the jawless survivor, the perfected parasite. What's the thread connecting them?
I think it's this theme of ancient cartilaginous fish finding these highly specialized, sometimes kind of frightening ways to survive for eons.
Right, sticking with what works.
Totally. The Chimaera's single gill, that venomous spine, they mark how different they became from sharks. The lamprey's jawless mouth, it's like a snapshot of vertebrate history, but it's still incredibly effective. Evolution doesn't always mean more complex. Sometimes simple and robust wins the long game.
These creatures seem almost primitive compared to, say, a modern tuna or marlin, yet they've endured while countless other species vanish. It really makes you think, doesn't it?
It does. And maybe that's the final thought for you, the listener. We've looked at things like the lamprey that barely blinked through 4 mass extinctions over 340 million years.
Yeah.
What does it tell us about evolution itself that these ancient, relatively simple forms have been so successful, so enduring, when so many complex, advanced species have come and gone? Maybe finding a really good niche, a solid survival strategy, is sometimes more powerful than constant change. They found what worked, and it granted them a kind of biological immortality.